Continuing on to topic 4 now, exponents, order of operations, variable expressions, and equations. So we're building up some basic material of mathematics that we'll use in algebra, giving you background, vocabulary, and some common skills to calculate and hopefully get right answers. These are the objectives that we'll cover. Objective 1, using exponents and order of operations. Now, first of all, what is an exponent? Well, we use it in what is called exponential notation, where we have a base 2 that if that 2 is multiplied by itself 3 times, we take the number of times it's used as a factor and we write that up here as an exponent. So we say 2 to the third power, where 2 is the base and 3 is the exponent. And what would that mean? Well, if we had a cube that was 2 by 2 by 2, to get the volume of that, that would give you a cubic centimeters, 8 cubic centimeters. Or 2 times 2 times 2 is 8. Okay, that was not too bad. And I think most of you are familiar with that. So it's asking you to evaluate the following. 3 squared or 3 to the second power. 5 cubed or 5 to the third power. And then here we don't have any special name, it's just 2 to the fourth. Here it's 7 to the first. And then the fraction 3/7 to the second. So in doing these things, as you see here, we can just use what they've written out. This would be 3 times 3, which is 9. Here it's 5 written 3 times. 5 to the third is 125. 2 to the fourth is 16. Now every number, 7 for instance, but every number has an exponent of 1. We just don't write it. So anything to the first power is just the number itself. And then here we have to keep in mind that we're squaring the 3 to get the 9, and we're squaring the 7 to get the 49. And we can do these because we have a little bit of time here. Think about it. 1 times 1 times 1 is 1. Don't mess up and say that that's 3. 5 squared, famous one, 25. This is going to be 1 over 100. This is going to be 9. And this will be 4. Nope, I got the wrong one there. 2 to the third is 8. And 5 to the third is 125. Now keep in mind that it's not 2 times 3. This is 2 times 2 times 2. Okay? All right, now we're going to move into what is called grouping symbols for a reason, because we're going to start order of operations down here. And what are grouping symbols? Well, the most common are parentheses. Another one is brackets. Another one is braces. Another one is the division bar. Another one is absolute value sign. And still another one would be the radical sign, anything under it. So in a sense, these are all grouping symbols, but we're basically going to use these to start off with. Now, in a case like this expression they're giving us, what do we do first? Do we add the 3 to the 2, or do we multiply first the 3 times 7? That is the question, because if you do it different ways, you get different answers. Now, one of the things that will help you do it correctly would be these grouping symbols. So if they grouped it this way, it's telling you to add the 3 to the 2 first. If they put the grouping symbols around these two, it's telling you to do that first. And for this, we think of what is called order of operations. You might recall this from whenever. Please excuse my dear Aunt Sally. And these letters represent the rules of order of operations. Parentheses and exponents, we're going to do those first. That would be grouping symbols for parentheses. Then, once we get rid of all of those, we do multiplication and division, going from left to right. Now, if division is first, we would do division first, then the multiplication, from left to right. And then finally, the last thing we do, addition, subtraction. And again, if subtraction's first, we would do that first. So, this is a little way to remember. I would suggest you take notes, but of course, the proof of the pudding will be, are you getting these things right? So here, with no grouping symbols, we would do the multiplication first, and that would be our answer. So let's look at a couple of these in some detail here. So as we look at letter A, what would you do first? Well, I would do this as a 25. That's my exponent. But then I would do this division, because from left to right, that then becomes the next thing. So this is going to be 2. So this is going to be 27. Now here, as we go from left to right, we're going to do the division first. So 20 divided by 5 is 4. 4 times 4 will be 16. Now here we're going to do what's in parentheses first. This will be a 15. 2 times 15 is 30. Now we go down below and we see we have a absolute value, which becomes a positive 15. So this will become a 2. Here we're going to raise 4 to the second power. We do that first. So this becomes 3 times 16, which is 48. Now here we have to do the multiplication first. And we can't cancel anywhere, so this is going to become 3/4 minus 1/2. Now, in order to do this subtraction of fractions, this has to be a common denominator. So we can elaborate or just make it 2/4. So this then becomes, now that they're common denominators, 1/4. And your practice and quiz-mes will show if you have developed mastery. And we did all of those. Okay, and here is some practice, and you'll be doing practice. Now here's sort of a complex example, and let's just look at it. So the first thing we would do is we have a grouping symbol. So this is going to be a 1, so we're going to have 3. This is going to just be a 1. And we can also raise that power to 4 now. All over, and we could do this subtraction if we want. We're going to have a 3 there. Now you might say, could you cancel out these 3's? Absolutely not, because these aren't common factors. So this is going to be 8 over 3. And there's another one. You're going to do this first. 36 minus 5 will be 31. This is going to be a 1. Now we have to do the multiplication first. 1 times 8 is 8. Plus 3 is going to be an 11, and that would be simplified. Okay. All right, let's take a look at this one. So when you have a series of parentheses like this, you do the innermost parentheses first. So this is going to be a 9. 2 times 9 is 18. This will be an 18 here. And then 18 plus 4 is 22. So we now have 3 times 22. That's going to be 66. And for example, 5, this is going to be a 6 here. We do that first. This becomes a 14. This is 4 minus 1 is 3. And there we have that. Okay, now we're going into our second objective, and it's to evaluate algebraic expressions. Now, an algebraic expression becomes that when in a mathematical expression we have a variable, which is a letter that is used to stand for something. Okay? So, in the expression, what does that mean? Well, 2 times x. Since there is no sign between a number and a letter, it implies multiplication. So these are equivalent. And when there is no sign between a number and a parenthesis, this implies multiplication. And the same for these things here. So now we're asked to evaluate algebraic expressions by putting in a known amount to replace the letter and then evaluate it. So in example 6, and again, you should write these out carefully in your notes wherever you're writing them. as you do your homework particularly, you're going to go 2, and now what was x? X is a 3, and again, a strong suggestion is put it in parentheses, minus, and then what was y? Was a 2. Here we don't need a parenthesis. So this is going to be 6 minus 2 will be a 4. And we do the same down here. Wherever the letter is, we replace it carefully with the value they're giving for that letter. Here they're not using parentheses. It's probably okay. Now in letter C, here we have sort of fractions. Well, fortunately, it works out that they're common denominators, so we can just add our numerator and get our answer. Now here for letter D, we're going to replace, let's do this one up here, the 3 for the x. I'm going to put it in parentheses and square it, and a 2 for the y and square that. So this then becomes 9 minus 4 is 5. And they give you more practice. It's done in the same ways. All right, for section 3 or subsection 3, objective 3, we're determining whether a number that will replace a variable makes the statement true, that is, an equation. We know that 3 plus 2 equals 5, and that these are all equations. And what's the difference so far between an equation and an expression? And the answer is the equation has an equal sign in it somewhere. Now, in an expression, you're asked to simplify. In an equation, you're asked to solve. Okay? So here has an equation. It has an equal sign, equation. No equal sign, expression. No equal sign, expression. Equal sign, equation. Okay. Now, when we have an equation, often we're looking for a value of our variable that makes the equation true. And we'll be doing that in chapter 2. So we're asked here, if we replace the x with a 3, does that make that true? Yes. But if we replace the x with a 1, it's not true. So we are asked to decide whether 2 is a solution for this. So what do? Well, wherever the x was, we substitute the 2. Here we get a 6 plus 10 is 16. 8 times 2 is 16, so that's true. And they'll give you others. All right, another major objective that we're going to be doing here is doing some translating English phrases to expressions and sentences to statements. And I don't know how much of this you want to put in your notes, but this is something you should look over. These are key words that indicate addition. Key words that indicate subtraction. keywords of is particularly of interest. Of implies multiplication, as do these others. Quotient, again, we're talking about division. The quotient of two numbers, we had said, was a fraction. It's also a ratio, but quotient. 2 divided by 4. 2 into 4. The ratio. 2 divided by 4. All of these. And then equal signs. Equals, gives, it was, should be, yields. We use that in chemistry a lot too. Amounts to, represents, is the same as. All of these would be translated into an equal sign. So let's look at our examples. And again, you will be practicing this. So the sum of a number and 3, and they want us to use x for the variable. That's important because sometimes they change the letter. If they say use A, use S, use B, here they're saying use X. And again, read these through. Now these, they don't give us the answers, so let's do those. 6 times a number. Remember, with no sign between them, it indicates multiplication. The product of a number and 9. Again, product indicates multiplication. The sum of 7 and a number. Sum indicates addition. A number decreased by 8. Decrease indicated subtraction. 2 times a number. 2x plus indicates addition. 3. There we go. And again, you'll be practicing this and getting your Quizme's. Now, here order is important. A number decreased by 10. That's straightforward. Now, a number subtracted from 10. Here the 10 goes first, then the x is subtracted. 10 less than a number. Well, there's the number first, minus 10. The number less 10. You put the number less 10. So, a helpful hint. That's exactly what it is. All right, we can write these before we look at the answers. Quotient, 15 and 4. 3 subtracted from 12 is the number. So we write 12 first, subtract it, subtract a 3, is an equal sign, x. 4 times a number, 4 times a number, added to 17 is not equal to 21. Triple a number is 3x is less than 48. We'll see how we did here. Oh, I read the first one wrong, didn't I? All right, read it. Quotient of 15 and a number. Okay, and is 4. All right. That's because I didn't read it properly. 15 and a number is 4. All right. I apologize for that. Reading it too fast. Okay, I think I did well on the others, so. Yep. Okay. And let's do this last one here. A number increased, which is addition, 13. 2 less than a number, there's the number, minus 2 is 11. Double a number, 2x, added to 9 does not equal 25. 5 times 11 is greater than or equal to an unknown number. Okay. And again, I could have put a dot there, but parentheses is a good tool. How are we doing for time? 26 minutes, not too bad. And then if you're using a calculator, they do give you some things. And that'll wind this up here. Okay, well, good luck with this lesson.